Welcome to the deep dive.
Yeah.
Today, we're going to be looking at physics education.
How cool.
Yeah, with a bit of a twist. And we have a really fascinating collection of materials to look at.
Okay.
We have like event summaries and project proposals and presentations and even links to physics simulations.
Wow.
Yeah, and it's all centered around this unique approach that's being developed over in Singapore.
So this isn't just like theoretical ideas. This
Right.
is something that's actually being put into practice in classrooms.
Exactly. So we're not talking about like dusty textbooks and boring lectures.
Yeah.
This is bringing physics to life through interactive simulations and like hands-on exploration.
That's awesome. Yeah, the heart of this initiative is something called physics by inquiry.
Oh.
And it's all about moving away from students passively learning and instead encouraging them to actively discover knowledge
Okay, so how do they do that?
through experimentation and problem solving.
That sounds like a pretty big change from the traditional way of teaching.
Yeah, it is. It makes you wonder what sparked this whole approach.
Yeah, I mean, where did this come from?
Well, our main source is this presentation that was delivered at the 2012 International Conference on Teaching and Learning with Technology.
Okay.
It was in Singapore. The title itself is really interesting. Physics by Inquiry with Simulations.
Okay, so they're really combining inquiry-based learning with technology.
Right.
But what does that actually look like?
Well, imagine a classroom where students aren't just memorizing formulas.
Right.
They're actually exploring physics concepts through these virtual simulations.
Okay.
So they can manipulate variables, they can test hypotheses, and actually see the results happen right in front of them.
So like instead of reading about gravity in a textbook,
Yeah.
they could like simulate planets moving around and see how gravity affects them.
Exactly.
That's pretty cool.
And the source material highlights 5 specific simulations
Well,
that were shown at this conference. One was a collision kart simulation,
okay.
and then 4 that were exploring all the complexities of gravity.
That's pretty complex to be able to make those simulations.
Yeah, you would think so. It requires some serious technical expertise.
Yeah, because not every physics teacher is like a coding whiz.
No, not at all. That's where things get really interesting. They're using something called open source physics, or OSP.
Okay.
It's this collaborative online platform, and it gives you access to this huge library of physics resources, including these simulations.
Okay.
And these simulations are created using software called Easy Java Simulation, or EJS.
Easy Java simulations.
Yeah.
So you're saying that teachers who don't know anything about programming can still create these interactive learning experiences.
That's exactly right. And what makes it even better is that they can be tailored to align with the Singapore syllabus.
Okay, so it's directly relevant to what the students are actually learning.
Yes.
So what's special about the Singapore syllabus?
It's known for being very rigorous and comprehensive,
Okay.
and it has this big emphasis on problem solving and critical thinking.
Okay.
So the fact that these simulations meet those standards says a lot about their quality and their value for education.
But even with all these amazing tools,
Yeah.
I imagine it's still a challenge to get teachers to change how they've always taught.
Yeah, you're absolutely right. Anytime you introduce something new, especially when it comes to technology, there's going to
Right.
be a learning curve for the teachers. You also have to make sure they have access to all the resources they need
Yeah.
and be prepared for some pushback.
So did they anticipate those hurdles?
It seems like they did. The source material mentions that the project actually received funding
Oh, wow.
from both the National Research Fund, NRF, and the Ministry of Education, MOE, in Singapore.
That's a pretty big deal.
It is. It suggests that the government sees real potential in this approach.
Wow.
It's not just a little experiment. They're actually investing in the future of physics education.
So they're really providing the support and resources that are needed.
Yeah, exactly. And what's even more amazing is that they want to share all of these resources with the world.
Really?
They're planning to make everything available under a Creative Commons attribution license. They're really embracing the whole open source philosophy of the OSP community.
Okay, so this is about more than just changing physics education in Singapore.
Yeah.
This is about helping educators all over the world create more engaging and effective learning experiences.
Exactly. That's what makes this deep dive so fascinating. We're getting a glimpse into what the future of education could be.
Okay, I'm definitely hooked. Let's dive into some more details about how this project actually came together.
All right.
Let's do it.
Let's do it.
So we've got this big picture view, but I kind of want to zoom in a bit.
Okay.
What can you tell me about the actual proposal for this presentation?
Oh, yeah.
I feel like that's where we'll find the real details of their plan.
Yeah, you're right. The proposal gives us this behind-the-scenes look at their process.
Okay.
And one thing that really stands out is their focus on being practical.
Oh.
They made it clear that this wasn't just some theoretical exercise.
Wait.
Well, they actually labeled their presentation as practice-based, which means they were showing actual results and experiences from working with students.
Ah, so it wasn't just hypothetical.
Yeah, not at all. They were walking the walk.
That definitely makes their claims more believable.
Right. And there's this other little detail I found interesting.
Okay.
They explicitly said that their presentation had commercial content. None.
Interesting. So they weren't trying to sell anything.
Nope. No hidden agendas or anything like that.
Wow.
They even went so far as to say it is all free for the purpose of benefiting humankind at zero cost.
That's a pretty powerful statement.
It is. You can really see how passionate they are about making education accessible to everyone.
Yeah, it seems like they really want to give back to the world.
Yeah, definitely.
Uh,
But passion alone doesn't make things happen.
right.
How did they actually get this project started?
Yeah, did they, like, bootstrap this whole thing?
Well, the proposal mentions funding from the National Research Fund and the Ministry of Education in Singapore.
That's got to be significant.
It is. It means this wasn't just a side project. They had serious backing.
Yeah, it sounds like those institutions really believed in what they were doing.
Exactly. And that support allowed them to go beyond just theory and actually implement their approach in real classrooms.
Do they say which schools?
Yeah, they mention working with River Valley High School
Okay.
and Yishun Junior College.
How many students and teachers were involved?
They worked with a total of 239 students
Wow.
and 7 teachers across the 2 schools.
That's a lot.
Yeah, and they even brought in educational technology officers.
Wow. They really went all out.
They did. It seems like they were trying to build a system that would last, not just a one-time experiment.
So what were their goals for these classrooms?
Their main aim was to get students to experience and figure out for themselves the physics.
Okay.
They wanted them to really understand the subject through hands-on exploration.
That makes sense. It's all about learning by doing.
Exactly. But they also knew it wouldn't be easy. They acknowledged that the slow diffusion of this ICT practice could be a problem.
Yeah, changing how people teach is never easy.
It's not. It
Mhm.
takes time and effort and a lot of patience.
So they knew there might be some resistance.
They did. And they knew they needed long-term strategies to make sure this approach would stick around.
So it sounds like they had a good plan
Yeah,
and the funding to make it happen.
right.
And they understood the challenges.
So that's a pretty good foundation for any project.
Okay, but I'm really curious about the simulations.
Oh, yeah.
What did they actually present at the conference?
Well, remember the title of their presentation, Physics by Inquiry with Simulations.
Yeah, it's a good one.
So they showcased 5 specific simulations.
Remind me what they were about.
One was all about collision carts.
Okay.
Students could virtually crash them together
Uh-huh.
and change things like mass and velocity
Cool.
to see how those changes affected the collisions.
I can see how that would be engaging.
Yeah, who doesn't love a good crash?
Right. What
Uh,
about the other 4?
Those focused on gravity.
Okay.
So students could explore how gravitational forces interact.
Interesting.
They could arrange celestial bodies in different ways and see how it affected their movement.
That's like having your own space lab.
Right. And this presentation was part of a session on ICT pedagogical practices.
So it's about more than just physics.
Yeah, it was about using technology to improve teaching and learning in all kinds of subjects. And they didn't just talk about the simulations, they provided links to them.
Oh, wow.
So people could actually try them out.
That's a great way to get people excited.
It is. It's like saying, don't just take our word for it, see for yourself.
Yeah.
They really wanted other teachers to see how powerful these tools could be.
Sounds like they wanted to empower other educators.
Exactly. But let's not forget about the technology that made all of this possible.
Right. Open source physics and easy Java simulation.
Exactly.
I'm really curious to learn more about those.
Okay, well, OSP is more than just a place to find simulations.
Okay.
It's a whole online community. Oh, wow.
Where teachers from all over the world can connect and share ideas.
So it's like a global network of physics educators.
Exactly. And EJS is the software that allows them to create those interactive simulations. It's designed to be easy to use even for teachers who aren't programmers.
That's really important. If you want people to use these tools,
Right.
they have to be accessible.
Exactly. And that's what's so great about OSP and EJS.
Yeah.
They make it possible for anyone to create and share educational resources.
It's like giving teachers the tools to create their own virtual labs.
That's a great way to put it. These tools have the potential to change how we teach and learn.
Yeah, make it more engaging and effective.
Right.
It seems like we've covered a lot.
We have. We've looked at the background of the project and the proposal and the presentation itself.
It feels like we have a really good understanding of this initiative now.
We do. But I think it's important to step back for a minute
Okay.
and think about the bigger picture.
This is about way more than just physics. Yeah, it really is. It's like we found this blueprint for a whole new way of teaching.
Right, not just physics, but maybe even any subject.
Exactly. It's amazing how much this project connects to so many big issues in education today, like technology and inquiry-based learning and open educational resources.
Yeah.
But what's really inspiring is the passion these educators have.
Right?
They're not afraid to try new things and really push the boundaries of what's possible in the classroom.
It's really cool how they've made these abstract physics concepts into something tangible.
Yeah,
It's not just information anymore, it's an experience.
right. These simulations are like virtual laboratories.
Yeah.
Where students can explore things that would be impossible to do in a regular classroom.
It's true. I mean, think about it.
Yeah.
You can actually manipulate the variables of a supernova.
Exactly.
Or like model how a galaxy evolves.
Yeah.
It's insane.
It really is. And it's not just about the wow factor either.
Right.
These simulations help students understand these complex scientific ideas on a deeper level.
So they're not just memorizing facts.
No, they're actually testing things out and seeing the results in real time.
They get to be scientists.
Exactly. But the question is, can this approach actually work for everyone?
Yeah. Can we really expect this to be the norm for every student?
That's a tough one. There are definitely challenges.
Like what?
Well, for one thing, teachers need to change how they think about teaching.
Okay.
And the whole education system might need to change too.
Right.
And then there's the issue of access to technology and resources.
Yeah, not every school has the same resources.
Exactly. But even if it takes time, I think the Singapore project shows us what's possible.
Yeah, it's a really inspiring vision for the future of education.
It is. It shows what happens when you combine innovative teaching with technology.
Yeah. And it shows how important it is to collaborate and share resources.
Imagine a world where every student can have these kinds of learning experiences.
It makes you wonder how we could use this approach for other subjects, too.
Yeah, like history or literature.
What if students could visit ancient Rome in a simulation?
Or interact with characters from Shakespeare.
That would be incredible.
The possibilities are endless.
It's not just about the technology, though.
No, you're right.
It's about encouraging students to be curious
Yeah.
and to experiment and to work together.
We need to help them become active learners.
Exactly. Not just passive receivers of information.
This deep dive has been really eye-opening.
I agree.
It's given me a lot of hope for the future of education.
Me too. It reminds us that learning doesn't have to be limited to a traditional classroom.
Yeah, we can make it much more engaging.
Exactly. And by using technology and encouraging inquiry, we can create really powerful learning experiences for students all over the world.
That's a great way to put it.
Thanks for joining me on this journey to Singapore and beyond.
Of course, it was my pleasure.
And to everyone listening, keep exploring, keep questioning, and never stop pushing the boundaries of what's possible.